Remember the early 90s when getting online meant tying up your phone line? That was dial-up internet. While similar technology existed since the late 70s, 1992 marked when providers in the US and UK made it accessible to regular consumers. The process was simple. Your computer's modem connected to a phone jack, dialed the provider's number, and both modems exchanged analog tones in a handshake to establish connection settings. The modem converted digital data into analog audio for phone lines while your provider converted it back. The catch? You couldn't make phone calls while online. Speeds were extremely limited. Though theoretically 56 kilobits per second, real speeds usually landed between 40 and 50 kilobits per second, sometimes lower with line noise or distance from the telephone exchange. Latency ranged from 100 to 220 milliseconds, making gaming, streaming, or voice calls nearly impossible. Modern broadband stays below 70 milliseconds. Today, dial-up exists mainly in remote areas where better options aren't available. It works for basic tasks like text, emails, or simple websites. It's cheap and widely available, but extremely slow, blocks phone calls, and suffers from high latency. Digital subscriber line sends digital data over copper telephone lines already in most homes. Unlike dial-up, DSL provides always-on connection and doesn't block your phone line because it uses higher frequencies that voice calls don't touch. First available in the mid-90s, major deployments started around 1998. It became popular in the early 2000s as a major dial-up upgrade. The system uses DSL, modem, and splitter to separate high-frequency data from low-frequency voice. Your modem connects to a DSLAM or DSLAM at the provider's central office, linking you to the internet backbone. Most homes use ADSL, where downloads exceed uploads, while businesses use symmetric DSL for equal speeds. Performance varies by distance from the central office. ADSL delivers 3 to 25 megabits per second downloads, sometimes 50, with uploads between 512 kilobits and 3 megabits per second. VDSL reaches 100 megabits per second over shorter distances. Latency is much better than dial-up at 10 to 60 milliseconds, making streaming, video calls, and gaming possible. DSL works best for small households or areas with phone lines but no cable. It's affordable, widely accessible, and offers consistent speeds because lines aren't shared. However, performance drops with distance, uploads are limited, and speeds lag behind cable and fiber. Satellite internet uses orbiting satellites instead of underground cables. Your dish sends signals up, the satellite relays them to a ground station, and internet comes back the same way. Older systems use large satellites 22,000 miles up. They work, but distance creates lag. Newer systems like Starlink use smaller satellites around 300 miles up, making data travel faster with lower delay. Speeds vary widely. Older setups give 12 to 25 megabits download, while modern low-orbit networks reach 50 to 200 megabits per second with better uploads. The biggest difference is latency. Old systems feel laggy, but new low-orbit ones approach cable or DSL responsiveness. Satellite fits remote places where other options don't exist: farms, small towns, cabins, RVs, even boats. It handles browsing, streaming, and everyday work, especially with newer systems. Trade-offs include weather sensitivity, possible data caps, and higher equipment costs. Fixed wireless internet uses focused radio signals instead of cables. The idea existed for decades but became practical in the late 90s through wireless local loop systems. As technology improved through the mid-2000s, it became faster and more reliable. Providers place equipment on towers fed by fiber connections. At your home, an outdoor antenna needs clear view of that tower. The signal travels through Ethernet cable to your indoor modem or router. Speeds typically range from 25 to 100 megabits per second, with newer setups reaching 300 to 500 megabits per second. Uploads are lower and latency sits around 20 to 70 milliseconds, much smoother than old satellite and usable for streaming and browsing. Fixed wireless works best in rural and suburban areas where wired options are scarce but you have clear line of sight to a tower. It's less effective in dense cities or areas with trees, hills, or buildings blocking signals. Trade-offs are line of sight requirements, weather sensitivity, and occasional speed variation. Broadband over power line tried delivering internet using electrical wires that power homes. Instead of installing fiber or coax, data signals layer on top of electrical current. Popular in the early 2000s, it never became mainstream. BPL injects high-frequency signals into power lines. Because signals weaken quickly and can't pass transformers, utilities add repeaters along the line. At home, a BPL modem plugs into an outlet and separates data from power, converting it to Ethernet. Performance ranged from 3 to 45 megabits per second with 20 to 70 milliseconds latency, but both varied due to electrical noise. These limitations made BPL less reliable than cable or fiber and caused radio interference. Today, BPL is used for smart grids and utility monitoring. Inside homes, power line adapters extend existing connections. Mobile internet lets phones and hotspots get online through cell towers instead of cables. It began with slow 2G data in the early 2000s. By the mid-2000s, 3G made browsing practical. Then 4G LTE arrived around 2010 and changed mobile use completely, making HD streaming and heavy apps normal. Today's 5G networks, introduced in 2019, push performance further with faster speeds and lower latency. Your phone uses its SIM and modem to connect to the nearest tower. Data travels as radio signals to that tower connected to the provider's core network through fiber. As you move, your connection transfers between towers. Each generation uses smarter encoding for higher speeds and quicker response. Performance depends on tower distance, congestion, and network quality. 4G LTE typically gives 10 to 50 megabits per second. Modern 5G delivers 50 to 300 megabits per second. Uploads are lower and latency improves each generation, 30 to 60 milliseconds on 4G, 10 to 25 on 5G under good conditions. Mobile internet is all about flexibility. It keeps smartphones online everywhere while commuting or traveling. It can serve as home internet in rural areas through dedicated plans, and many use it as a backup. Main strengths are convenience, no cables, and wide coverage. Modern 5G can rival wired broadband. Trade-offs are variable speeds and costs depending on data plans. Cable internet delivers high-speed access through the same hybrid fiber coaxial cables used for TV. First available in the mid-90s, the first service launched in 1996 in Hartford, Connecticut. Adoption grew rapidly as the DOCSIS standard matured. The system uses unused frequency space on coax TV cables. A cable modem connects to your provider through the line with data traveling to a CMTS at the operator's head end. Because neighbors share the same line segment, speeds may change based on how many people are online. TV and internet use different frequency bands, allowing both on one cable. Speeds vary by plan, congestion, and DOCSIS version. Downloads range from 50 to 500 megabits per second, with high-end plans exceeding 1,000. Uploads are much lower at 5 to 50 megabits per second. Latency runs 10 to 40 milliseconds, making cables suitable for gaming, streaming, and video calls. Main advantages are fast downloads, wide availability, and strong performance. Drawbacks are slower uploads and potential slowdowns during peak hours due to shared bandwidth, plus higher pricing than basic DSL. Fiber optic internet uses thin glass or plastic strands to send data as light pulses. It's the fastest and most reliable home internet today, far outperforming copper systems like DSL and cable. Though the concept existed for decades, true fiber to the home began rolling out in the early 2000s with major deployments around 2004. Fiber carries information using light instead of electricity. In full setups, fiber runs directly from the provider to your home and connects to an optical network terminal that converts light signals to your router. This naturally supports equal download and upload speeds. Fiber is extremely fast and consistent. Entry plans start around 300 to 500 megabits per second. Many offer 1 to 2 gigabits per second, and premium areas reach 5 to 10 gigabits per second. Latency is extremely low at 1 to 10 milliseconds, making gaming, video calls, and cloud apps feel instant. Fiber is perfect for busy homes, creators, and remote workers needing stable performance. Main strengths are speed, reliability, symmetric uploads, and interference resistance. The main drawback is availability. Not all areas have fiber yet, and installation often requires new physical lines, which can increase upfront costs. Each of these technologies represents a different solution to connecting us to the digital world, from the nostalgic screech of dial-up to the lightning-fast pulses of fiber optic light. If you find that you loved this technology video or would like to see more, why don't you like and subscribe? It's pretty simple. You're using the same thing that we've just discussed to be able to hit that and send that appreciation our way. And add light speed. Stay tuned for more.